All right, for this week's homework, we have your bell work, which will be done each day at the beginning of class. And then moving to the first problem, it says identify this graph's slope. So in order to find slope, we are in need of pretty points. And since they are not identified on this graph, we need to identify them ourselves. Something that I have talked about in my class is the location of a pretty point is where a horizontal pre-made line and a vertical pre-made line intersect right on the graph. So if you notice, this is where this vertical and horizontal intersect right on the graph. Whereas this one here, it only has a vertical intersection. This one only has a vertical intersection, a vertical. This one only has a horizontal. So these are the pretty points that you'll want to use to find your slope. So slope equals rise over run. So in this case, we can first identify our graph as positive or negative. So if we remember from slope dude, we have puff positive and nice negative. So what I like to do, if it's confusing if it's positive or negative, I like to extend the other end of the graph like this. So then we could say puff positive, and then this would be nice negative. So our answer in the end is going to be a negative. And then our rise is going to be, I'm going to use here in red, our rise is 1, 2, 3. And our run is 1, 2, 3, 4, 5. And so when you have your rise over run, it's going to, so I did it in two colors like this. So make sure to distinguish between that one. So this one says identify the rate of change in this graph. So again, rate of change, so rate of change equals slope, which equals rise over run. So again, we have our pretty points already identified for us. So then all we need to do is rise over run. 1, 2, 3. So rise over run. So use those numbers there to get your answer. And again, if you were using this, it would be puff positive, nice negative right there. So make sure that your final answer will have a negative in it. Okay, this says identify the type of slope. So the type of slope, there are 4 different. There is positive, negative, 0, and undefined. So what I'm going to do is draw this creepy slope dude. So I'm going to draw some eyebrows. So this would be puff positive. This would be nice negative. I'm going to give him a nose, and that straight up and down is undefined. And then straight lines like this are 0. So that U equals undefined, and that the 0 stands for 0. So go ahead. And then when we're talking about steepness, so steepness is like if you were riding a bicycle, if you're riding a bicycle up a really, a hill that your legs are super tired. So if you're riding a bike on a super steep hill, this is a lot harder than if you're riding your bike on a hill that maybe looks like this. So this here is more steep than this one here. This one, so thinking of steepness as like how steep a mountain is, how steep a a hill is, something like that. So look at those. All right. So identify the unit rate in each, then circle the steepest graph. Okay. So remember, unit rate equals rate of change, which equals slope, which equals rise over run. I think rise over run is the most common for graphs. So we're going to have to find our pretty points on this graph. So let's see. Seems like there's quite a few on this one. So we only need 2 in order to find our rise over run. So our rise is 3, and our run is 1. And then here we have pretty points. Again, there are these points that are nicely intersecting the graph. So we're rising 1 and running 1. So then looking at these graphs and determining, so make sure to simplify and identify the steepest graph. So go ahead and circle the one that's the most steep. So thinking of a mountain, like the closer something is to a vertical, that's the more steep it is. So we did this in our notes and kind of throughout this paper. There are all the different types. So in our notes, there are different words. I'm going to give a couple of them. I've been kind of listing them throughout this video already. Equals slope, which equals rate of change. And then there are more. So you're going to want to use your notes to look at those ones. All right, is this graph proportional? Explain. So it's not asking us to find the slope. So we need to know if we were to assign for example, if we have if this is, I know from class we had cups of flour to cookies. So remembering that if it's proportional, if we have 1 cup of flour, that makes 3 cookies, then 2 cups of flour will make 6 cookies. And so on 3 cups of flour will make 9 cookies. So we're multiplying each. So we're multiplying by 3 to get from here to here. So if we have, so this right here would be an example of a proportional relationship. So if we had 0 cups, how many cookies? So hopefully you thought, okay, if I had 0 cups of flour, I would have 0 cookies. So knowing that when you plot, so 1, 3, 2, 6, so and then knowing that 0, 0 is going to be on your graph. So all proportional relationships go through the origin. So that is one way you could explain that one. All right, again, we have identify the graphs M. So M equals rise over run, equals slope, equals rate of change, equals unit rate. So they've given us our pretty points. So we're going to want to identify a rise, 2, 3, 4. and a run of 1, 2, 3, 4, 5, 6, 7. So a rise over run. So rise over run. And then determining, again, whether this is positive or negative. So remember, right here we have puff, puff, positive, nice, negative right here. So making sure your final answer has the correct sign in it. All right, this one, it says find the slope using these coordinate points. So we could draw up and graph, but these points are pretty big, so I'm going to use the slope formula that states the slope equals y2 minus y1 over x2 minus x1. So I'm going to go ahead and label. This would be x and y, x and y. So right here, I'm going to label this first coordinate as 1s and then the second coordinate pair as 2s. What I like to do is circle the number that is associated with the y1 or y2, and then draw your line and your subtraction sign before you start. And then you're going to go ahead and circle your number. So if you had this y2 is going to go here. So this would be this number. So maybe this y1 is right here. And then making sure your colors match your... So if this was x2 and x1. So making sure all of our colors go into the correct places. So our y2 is going to be 8 minus 17 and 19 minus negative 5. So then in your calculator, if you're at the school, you can use, you'll want to put it in a fraction. You can go alpha y equals, and that will give you the little fraction box. And then you can put this directly in just like that. All right, we are looking for the rate of change, which is the slope, which is the m, which is the rise over run. And I'm going to go ahead and label x1, y1, x2, y2. And we have our slope formula, m equals y2 minus y1 over x2 minus x1. So draw the line and subtraction sign, and then put the numbers that are associated with it. So we have negative 19 minus negative 3 and negative 19 minus 17. So something, if you're ever worried that you have the wrong numbers associated with it, your numbers are always going to be on top of each other. Your coordinate pairs are going to be on top of each other, So if you end up getting an answer where you have green and pink like this, that would be, I don't know if you're using colors, but that would be wrong. So you're always going to want to have the same colors, and then right in the middle of those colors, you'll have your subtraction sign, because that subtraction sign will be in every single problem. So make sure, if you're doing it in your head, make sure you're simplifying completely. All right. Does this data represent a function? So I just wanted to review. A function is talking about functions refer to the x values. So, meaning, if you were to plot these points, they would pass the vertical line test. So a function is talking about the vertical line test. So we have here, we have a 1, 2, 3, 4, and 5, and these are all the x's are different. So this is going to represent a function. And then if you're curious, you're more than welcome to, I can draw maybe a little. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So again, if you were to draw that line, and if you were looking at a vertical line test, so if this was a vertical line, it would only touch, so this would pass the vertical line test, and so you could see if it was a function that way. And this one says, does this data represent a proportional relationship? So proportional, so this is also a function, and then we're determining whether it's proportional or non-proportional. So proportional is referring to our y equals kx, or if we were to set up y over x equals y over x. So I'm going to show you both ways here. So if we wanted to use, you would have to check all of the points. So I think personally this one right here is easier, seeing if all this is easier. So taking all of your y's, 2 over 1 equals 4 over 2 equals 8 over 4 equals 16 over 7, and checking them. So 2 over 1 is 2, okay, and 4 over 2 is also 2. So these both equal 2. 8 over 4 equals 2, so these are all equal so far. But 16 divided by 7, this right here is not equal because these all equal 2, but 16 divided by 7 is not 2. So you have to check all of your y divided by x's in order to determine proportionality. What are indicators of a proportional relationship in a table and in a graph? So we just saw here, so this example right here, if a graph is proportional, that would mean that every y over x would result in the same k, or some type of, the ratio is always the same. So 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, and then the next one, it would have to be 16 divided by 8 is 2. Whereas in a graph, I want to refer back to our example here. So remembering that if you have a proportional relationship, at 0 cups of flour, you're going to have 0 cookies. If you work 0 hours and you're an hourly employee, you're going to get $0. So remembering that all proportional relationships, when graphed, will pass through the origin because of that relationship that proportionality creates. So I hope that helps and you're able to come up with a reason why, or an indicator, or a explanation of proportional relationships in tables and graphs. And that is all, and I hope this helps